All right, so can you guys see my screen now? Hello?
Yes, sir.
Is my screen visible? Okay. So as you guys can see, this is already probably already our last discussion. So this is already the week 9 to 11. So as you guys can see, we already have the last 3 tasks, which will be due on July 28th. So you guys have exactly 3 weeks to finish these 3 tasks. Anyway, this will be just a short discussion since this is just a continuation of the previous module. So one, the instruction set. So this is already the letter B. Wherein we're going to talk about still about looping. Okay. So are you guys ready now? Can you guys give me thumbs up just to let me check if you guys are already in front of your computers? Okay. So 3 out of 4. So I don't know where Miss Garcia is. Anyway, so let's talk about looping. So it's still looping. So loop again is the sequence of instructions that is executed repeatedly. So we have here the syntax for the loop. So very simple loop and then the label name. So it could be any name that you can think of. Okay, so it's literally a variable that you're going to name a certain character or a certain word. So a loop instruction creates a loop that is to be executed in a specific number of times. So that's what's called loop. So the loop instruction uses the CX register as a counter that keeps track of how many times the loop is to be executed. So when it comes to using a loop, just use CX because that is the specialty of the CX register. This one is made for the counter. So to use the loop, start loading CX with the number of times you want to execute the loop. So here is the reverse syntax. So move CX and then how many times you want to loop, that certain function or that certain let's say code, okay, or line of codes. And then uh, L1 is just a label name, and then the code that you're going to execute if you're going to uh, make this loop break, and then loop L1 to go back to this L1. So it will keep on looping until the CX became 0. So every time that it will loop, it will deduct 1, okay, to the value of our CX. So if we say 5 for the first loop, the second time it's now 4, third time is 3, second time is fourth time is 2, and then fifth time is 5, something like that. Did I say it correctly? The first loop is 5, and then 4, 3, 2, 1. So it's decrementing by 1, something like that. Okay. So loop jumps to the specified label. So depending on the naming of your label, so you can change this one into any name that you guys can think of. So we have here a sample code. So let me just recreate this one again. Code ex beta. Let's try this one. So let's try this one out. So here is the label name. Okay, so BL is just an initial value. Okay, and CX is our counter. So as you guys can see, we want to have a looping of 3 times. So L1, increment BL, and then loop L1. Okay, so every time that this loop will be executed, so it will increment the value of our BL. So starting from 5, then it would go to 6, 7, and then 8, since it will loop 3 times. And add BL 30H. So we are adding 30H right here since as I guess you already know the BL is in 8, right? So in hexadecimal, so just like last meeting, So just like last meeting, if it's 8, in decimal or hexadecimal, the one that we can see is the character wherein we will see backspace. So if you want to see a certain character, so we should start right here, 33. So that's exclamation. We will say exclamation if we have a value of 33 equal to the character, to the exclamation. And then as you guys can see right here, we have here 5 initially plus 30 is 35. So that is our starting point, 35. And then if we are going to add 3, since it will do 3 times, 35, 36, 37, 38. Is it correct? 38, 38. So we'll get a value of ampersand. Okay. So this is what we should get after getting the final value. Okay, but we'll see. It's really ampersand because when I tested this one last time, it should be 3 or 8. So anyway, we'll see. Okay. Let's go back right here and lacking some of the codes, move BL, and then we're going to display that one using this interrupt. So 0 to H, interrupt 21H. And then we're going to close that one using this interrupt. So move AH, force EH, and then interrupt 21H, and then end. So let's try this one out. So we have here a value of 8. Let's check. Why is it 8? But only getting a value of 38. 30, same as adding, my apologies. Okay, so this one is not in decimal anymore. This one is in hexadecimal. Okay, so we have H right here. So let us check where is that H for 30. 30. So 30 is equal to 48 in decimal. So this one right here is in decimal since it doesn't have an H, a unit right here. So 30 is the equivalent value of this 30H. So in decimal, that is, so hexadecimal, right? 30, and that is 48. Okay, so 48 plus 5, 49, 50, 51, 52, 53. And we're going to loop or increment this one 3 times. So 54, 55, 56. So that is why we have here a value of 8, okay, as our character. So did you guys get this one so far? Our first example. So the equivalent of this 30H is 48 in decimal, plus 5 is 53, and then we'll increment this one 3 times, or this will do 3 times. So 53, is it correct? 48 plus 5, 53 plus 3 is 56, wherein 56 is equal to 8 in characters. That is why we are seeing this one as the result. So were you guys able to get this one? So there's only one. So let's try to analyze this one, from the very start. So we have 5 as in decimal. That is a value of BL. And then here is our counter. Again, CX is, how many times you want to loop this certain loop. So yeah, we want to loop this one 3 times. So as you guys can see, we have here a function of increment. So this increment will just add 1 to our the value of BL. So from 5, of course, after looping this one time, the value of this one now is 6. And then it will loop again, okay, since the value of CX is not yet 0, so we still have 2. So another one, this one now is 7, so we still have a remaining 1 loop, so another loop. So from 7, it will become 8. And then once the value of Cx became 0, then that is the only time that we will stop, since the the value of Cx is already 0. Okay, so just to take note that if Cx is not equal to 0, then loop jumps to the specified equal. So it will go back right here again, and then it will loop again. Okay. So are we clear to this, up to this part? So the value of DL now is 8, right? Hello? Please use your mic so I can also hear that you guys are really listening. So I don't even know anymore if you guys are really there or no. Okay. So just respond if it's not clear, and just respond right away if it's clear or you have a problem. See, so anyway, so the after the line of the value of the BL is 8. So we're adding 30 each in hexadecimal. So just to take note that we have to convert, either one of those. So let's just convert this one into decimal. So 30 each in ASCII code, in hexadecimal, 30 is equal to 48 in decimal. So this is already decimal. So 8 plus 48 is 56. So 56 is equal to 8 in characters. So that is why we have here a result of 8 after running the entire program, example program. Okay, so this will just display the character, and this will just end the program. Okay, similar with that. So I hope we're clear with this one. So just let me know if you guys need to analyze this one a little bit more, so I can give you guys time, maybe 3 to 5 minutes. Reset pa na. All right. So let me call you guys one by one. Mr. Pulmano,
Clear, sir. Clear.
thank you. Mr. Mina,
Yes, sir.
is it were you able to get this one so far?
Sir, nakakuha ko po yung idea pero baka skim through ko na lang mamaya. Para sure po ako.
Okay. What about you, Mr. Ben Iman? Wala akong narinig. I think your mic is not working. Anyway, what about you, Miss Garcia? She's not around. Okay, so imagine. What part? From what part? So up to line 12. So let's try changing some of the codes. So if I will change this one into, let's say, 2, then this loop will loop 2 times only. And this increment will increment 2 times only, of course. So it's like you already know the answer. It's like 5 plus 2. So we'll get a result of 7. If we change this 1 into 1, then of course, this will only loop 1 time. So this will, the value of BL will only be incremented 1 time. Okay. So from there, we'll get a value of 6. Okay. So if we change the value of BL, so we can also do that 1 plus 8 to 55. But I'm not sure anymore what is the expected result. But let's see 30. Okay. So 30 plus 1 is 31, plus 3, plus 48, since this one is in hexadecimal. So 30 plus 31 plus 48 is 79, right? And in ASCII code, 79 is O. Okay. So that is why we are getting this one as a result. So if you want to get, let's say, letter P, let's make this one 1. There you go. So we have a result of P. Okay. Let's say we want to get S. So what about adding more loops? So from P, we want to loop this one 3 more times. So 1 plus 3 is equal to 4. There you go. Okay. So are you guys getting this one now so far? Okay. So I go to stock I miss Garcia anyway. Okay. So that's how looping works in assembly language. Okay, so CX, how many times you want to loop this one? And of course, that depends on your code. What will it do to the, let's see, BL, you want to increment, you want to decrement, okay, and so on. All right, so anyway, so that's it for the first example. So we also have here a loop with comparison. So this one is with condition. So see, with conditions, loops that also depends on the result of the comparison. So add comparison directly before the loop jump. So we only have two. So we have the loop E and then the loop NE. So E is equal to equal, and then NE is equal to not equal, or stands for not equal. So I guess it's very straightforward. Loop E, if it's equal to the value, then it will keep on looping. But if it's not equal, then it will stop looping. And then vice versa. If loop NE is not equal to the value, then it will keep on looping. But once it is equal, then it will stop looping. Okay. So we have here an example. So let's try to analyze this one first before I will transfer the entire code and then check the output. So we have here the value of BL, which is equal to 0. And then we have here a counter of 5. So we want, as you already know, this is the counter, or how many times we want to loop a certain loop. Okay, so we want to loop this one 5 times. Okay, actually up to this part right here. Okay, L1 up to this line 20. Okay, so in here we are already adding a value of 30H, so it's in hexadecimal. So you guys gotta convert this one into decimal, which is 48. So they are just the same. So by default, we're going to start with, so where is 40? We'll start with 0. Okay, so in here it's like we already know that this will do 5 times. Okay, but we'll see. So that depends on the condition. So L1 will increment the BL, and then we have here another condition. So move BL, move EH as 0 to H. So in here, it will show already the previous result, okay, or the first result before it will loop again, and then will show the second result, and then will loop again, and then will show the results, or something like that. So instead of having a one result only, it will show the result on every loop. Okay, so you guys will see how many times it will loop. Okay, same with the corresponding result of it. So that's it for this move AH 0 to H and then in 21H. So here is now the condition. So compare BL 33H. So loop not equal to L1. Okay, so if it's not equal to L1, say this 33H, where in 33H is 3 in decimal, or in character, let's see, I think it's 33 hexadecimal, yeah. So that one is 3, okay, in character. So as long as it's not equal to 3, then it will keep on looping, okay? So then after that, once it's already equal to 33, then it will stop looping. And then move AH for CH in 21H. We'll just end the program and end. Okay, so let's try this one out to further understand this code right here. L0 5. So in character, this 1 is equal to 0. 1. So in character, this one, DL0, 0 is not equal to 0. Okay, character. That is actually equal to null. Okay, and this is the one that should be equal to 0. This 38 right here. So 30 is equal to 0, or 48 in decimal, that's equal to 0. And increment by BL, so just plus 1 to the value of BL. And that is our looping statement for this one. And then we have a comparison wherein, wait a second, this is not part of our code. That is for the last one. Increment BL and move DLBL, move DLBL. Yeah, that's right. And then move AH0 to H, and then in 21H. And then compare BL. If it's equal to 33H, we're in character, this 1 equal to 3. And so as long as it's not equal to the value of 33, it will keep on looping. Okay, but once it's already equal, then it will stop looping already. Okay, so let's try this one out. Increment BL. So there you go. You see, this one is the first loop, that is the first value. So it incremented by 1, and then it loop again since it's not yet equal with this 33H, since that is equal to 30H initially. And then it loop again another 1, so it incremented by 1 the previous value of BL. So 1 plus 1 is equal to 2, and 2 isn't still not equal to 33H. Okay, because 2 is equal to 32H in hexadecimal. So of course it will loop again. We'll go back right here to line 13, and then we'll increment by 1, and then that is now the value of 3. And as you guys can see right here, we have a condition wherein if it's already equal to the 33H, it will stop looping already. Okay, and then we'll close the program. Okay, so that's how we've got the value of 1, 2, and 3. So if you guys are going to check this one again, so there's a delay 1, 2, and then 3. Okay, so first loop, second loop, and then third loop. So if we're going to change this one into 35H, so it's like we want to loop this one until the value of your character is already equal to 5. Since 35H in ASCII code is equal to 5. So as expected, this will loop 5 times. So we'll give us a value of 1, 2, 3, 4. Oops, why is it stopping at 33H? Maybe it wasn't able to. Okay, let's try this one more time. There you go. So we have 1, 2, 3, 4, 5. So if you guys would like to loop this one 10 times, then maybe we can change this one into 10, since even though this one is already 40H, but our counter is only up to 5 only, then it will still only loop 5 times. Okay, so if you guys would like to loop this one 10 times, or let's say 9 times, okay, so even though it haven't reached the value of 10 yet, which is equal to 40 each, 40 each. 40, 40, 40. We don't have 40 in hexadecimal, so that's 3A actually. 40 in hexadecimal is at sign. Okay, so if it's 9 only, okay, so 39 is equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you want to get the value of at sign is 40 right here, we have to change this 1 into 10. Let's emulate and then write. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a colon. But I think get the value of 3A. 40 each. That is where I'm not sure why it's getting the value of 3A. But what about if it's 3A? Right, equal to this 3 each. Are we going to get the same result? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So I'm not sure why, but 40 and 3A is equal to this column. Maybe we have to add 0 right here to get the value of the exact 0, 40 each. Emily. Since we want to get the value of at sign. In hexadecimal, 1, 2, 3, 4, 6, 10, 11, 40, 41, 42, 43, 44, 45. What about if this is 45? Let's see. Did it run? We will not reach that one since our counter is only up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 40, 41, 42, 43, 44, 45. Exclamation. Question mark rather. 46. Let's make this 160. So yeah, I don't know what happened, but it seems that this hexadecimal 46, this 40 right here in hexadecimal is equal to 46 each. So starting from this 39, okay, so we have to count one by one. So 40, 41, 42, 43, 44, 45, 40, 41, 42, 43, 44, 45, and then 46. So I think the hexadecimal right here is not that accurate. So maybe we should just try the decimal. Okay, so instead of using 30H, let us try to use 48 and then just use purely decimal instead of relying with this 3A, 3B, 3C3. Okay, decimal. Which is 1 into 48. And this one is, let's say, 64. Increment by 1. Okay, so let's try this one. So we should get the same result, but it's now in the form of a decimal. Or by the way of decimal, okay, not in the form of decimal. Since what we're still getting is the character. 3, 4, 5, 6, 7, 8, 9. Yeah, there you go. So I think decimal is much more easier to understand since starting from 0 up to 127 is just incrementing by 1. Unlike in hexadecimal, so we have 0 to 9 and then E to F. 10 to 18, which is now, quite confusing. And then 1A to 1F, and then 20 to 29, 2A to 2F, and so on and so forth. Okay, so if you guys would like to get the value of, let's see, add sign, okay, so just use decimal. So we maximize this one up to 64. So once it reach the value of 64, or once the value of BL is already equal to 64, then it will stop looping already. We're in, that's the add sign. So are we clear so far for this second example? What about the others? What about Miss Garcia, Mr. Belingan, Tu Garcia, okay, Miss Maxine, and then Miss Sophia, and then Mr. Kapuag? So I don't know, maybe they are eating their lunch already. So I hope you guys were able to get this one. Okay, so instead of using hexa, just use decimal. I think that's much more reliable and much more easier to understand, and much more accurate. Okay. So yeah, that's it for the example. And then as you guys can see, we only have 2 examples. So that is why I maximize our time, and then I will explain them, since we only have 2 examples. And then here I know your tasks. So task 3.5, task 3.6, and then task 3.7. So for the task 3.5, so display sets of asterisks based on the user's integer input 0 to 9. So we have an example right here. So the user input is 6, so it will give us a result of 6 asterisks. If it's 9, then 9 asterisks. If it's 3, then 3 asterisks. So very easy for 3.5. So we have here a much more complicated, but not it's not actually that complicated. So this is like a game wherein you're going to ask the user, wherein you're going to compare the inputs. So if it's higher than the magic number, so we call that one the magic number for the first input, and then it will display lower. If it's less than the magic number, that will display higher. So if they are equal, I mean, not yet. Okay, if it's non-integer rather, okay, it will display not a number. And then in case of A, B, and C continuously ask player to enter a number until case C was met, then if equal display congratulations. So once it was already able to guess the magic number, okay, that number that was specified in there, then it will say congratulations. So you were able to guess the number correctly, or you were able to guess the magic number correctly, and then end the program. Okay. So it will keep on asking until the magic number were guessed correctly. Okay. So we can also do this in the form of a table DB, or let's say array. I suppose I would say array, but it's not an array. So this one is in a table database. So we have here the value of number 1, number 2, number 3, number 4, and number 5. So the same with the indexing. So this is 0 index, first index, second, third, and then fourth. Okay. So we have here the same until line 8. Okay, and then we now have here a new variable, which is SI. So this one is a register. SI is used to perform indexing. Okay, so we'll start with 0 indexing. So we have here a loop 1. So move BL. So they note this is BL, not B1. Okay, I'm pretty sure that this is 1, but this one should be BL. Okay, maybe Ma'am Suarez just mistyped this one into B1. And then we have B bolt SI. So we are getting the value of the SI, okay, which is initially 0, and then transferring that one into our BL. And then we are adding a value of 38 again, where in decimal it's 48. Okay, and then move BL, move EH 0 to H, so this one will just display. And then we have here, we'll increment the SI by 1. So starting from 0, we'll increment 1 into index 1, index 2, and so on and so forth. And then compare the value of SI if it's already equal to index 3. Okay, so once it's equal to 3, then it will stop looping already. And then we'll Alright, so while waiting for the others, let me just transfer this one. We have So I don't know, maybe they're not going to join anymore. But so here is the result for the looping and array. Okay, so from this table, okay, so we are getting the value 1 right here, 2, and then 3. So as you guys can see, but let me just check. This one is 0. Yeah. Okay. So we've started with 0 index, and then we've incremented by 1. 0, 1. Wait a second. I'll just verify one thing. Plus 1 plus 2 plus 3. Yeah, that's correct. Okay. So we've already add here a 30H. Okay, where in 30H again is equal to 0. So by default, we have a value of 0 in characters. So we just increment that one by 1, by using this table. So this is equal to 1H, 2H, and then 3H. Okay. So the first loop incremented by 1, so that's why we are getting a result of 1. The second loop incremented by another 1, so that is why we are getting the value 2. Or we could also say that it did add the second index, okay, or the most or the more proper term is first index, okay. So this is 0 index, and then this is the first index, okay. So plus 2, okay, for the hexadecimal for the second index, and then plus 3, okay, for the hexadecimal for the for the second index, okay. So if we're going to change this one into what can we change right here? So maybe 5, okay. So we are going to loop until this 05H. Okay. So we'll get a value 1, 2, 3, 4, 5. So this one is similar with this one right here, but it's just in a form of a table. So instead of starting with 0 decimal, okay. So in here you're starting with 1 hexadecimal. Okay. Okay. So are we clear so far for this last example, is looping an array. So this increment si right here is basing that one on the given value. So let's try one more example, I think. So this is the first loop, second loop, and then third loop. What if we'll change this one into, let's say, 7h, and change this one into 3. So we are expecting a result of 37, wherein 7 or 37 hexadecimal is 7. So let's try that one out. So there you go. So it's 127. Okay, so it is not incrementing by 1, but it's adding, okay, whatever is the value of that index. So you are getting the, it will loop 3 times. So this is the first index, another 0 index, okay, first index, and then second index. Okay, so that is what we have here, value of 7. So if this is 5 and this is 2, then we will get 2, 5, and then 7 as a result. It's like basically we're just displaying whatever is in our table. Okay. So of course you have to follow this format wherein of course you're going to start with 30h, so that we will start with 0. Okay, because 30h is 0. So there you go. Are we clear so far? Let's display everything. 25745. So were you guys able to follow? Our last example. So 1 out of 3. So just let me know, guys, Mr. Mina and then Miss Garcia, if ever you guys have a concern, just message me. Okay, and that is already for looping with comparison, or looping and array with comparison. Okay. And for your last task, this task 3.7, so looping and array, modify the looping and array sample code, this one right here, to add the following functionality. So allow user to enter a number from 0 to 9, display if the input is found in the table, and then if it's found, then just see item found. Otherwise, display item not found. Okay, so we have an example right here. Of course, it's ranging from 0 to 9. So the user inputted a number of 3, so it's item found. If it's, wait a second, why is it item not found on 7? Okay, so maybe it's already basing on this table DB. So table contains the same data as the example. So 01H, 02H, 3H, 4H, and then 5H. So of course, as you guys can see, we can only set 5 results for the item find. That is the 1, 2, 3, 4, and then 5. And then 6 and above, 6 to 9, is already item not found, because it's not part of the table. So just use the same table, okay, as given on the example, this 0 to 0, 5 only. So do not modify that one anymore.
Recording in
Okay. And yeah, that's already it for the task 3.7. So are we clear? Hello? Are we clear, guys? So I can only ask the 3, who were able to attend earlier, Kabuwag, Mina, and then Garcia. Okay, but for Mr. Pulman and then Mr. Tanikal, of course, they do not know what I'm asking anymore since they are late. Anyway, just watch the recorded Zoom meeting later on. But before we end our meeting, so one more time, do you guys have any questions or clarification? So maybe we can go back one more time since we still have 3 more hours to be exact. So starting from the first example, second, and then third. Questions or clarification? So I guess you guys don't have any other concerns anymore. Not even sure if you guys are in front of your computers. But yeah, the due dates of your activities will be 3 weeks from now. That would be on July 28th. And then the coverage of your final exam will be, of course, starting from, wow, so there's only 2 modules. Okay, so just module 3C and module 3D. Yeah, actually it's just one module. This one is just a continuation of this module 3. And yeah, your final exam will be on August 4. Yeah, that is August 4. Okay, so maybe I'll publish one more module. Okay, but that is just a summary of the arithmetic. Okay, the multiplication, division, addition, subtraction of the module 3. So any questions or clarification so far before we end our meeting?
None, sir.
Okay, so if you guys don't have any other questions anymore, then you guys may not go. So as always, thank you guys for coming. I still really appreciate it, even though I'm not even sure if you guys are in front of your computers, but you were attending our Zoom meeting, so that is very big thanks for me. Okay, so yeah, see you guys. Maybe I'm not really sure because this is our last discussion already. So we'll just meet maybe if you guys have a lot of questions. But if no one is asking, then I'm not even sure if you guys have questions or not. So just message me first, okay? And then probably if most of you a lot of concern has a lot of concerns, then we can meet next week or next week. Okay. So just let me know, guys, if you are having a problem with those tasks or activities. Sige, Mr. Tanikala, it happens, My case, I am also late sometimes. So just watch the recorded Zoom meeting later on. Okay, so you guys may now go. Happy lunch to all of you.